Hi, this is going to be an overview of how we hear. Hopefully I'm not too shaky here. I don't have anyone to really teach this to here in my house, so we can just pretend like maybe we're on FaceTime and I'm teaching you as the parent of a client. So I have here a diagram of our ear, and the ear is actually a lot bigger than we actually tend to think of it. We really just think of this outside portion, but we've separated the ear up into three main categories. So we've got our outer, middle, and our inner ear, which you can see here. And the outer ear, again, is this traditional idea of what an ear is. So it consists of, right here we have what we call the pinna. We have our ear canal, and then this eardrum, which is this portion just right there. Sort of the function of this outer ear, this pinna here, is going to collect sounds. You can see how I'm kind of cupping my hand, how it's shaped. So it collects the sounds that are coming from all around us and really funnels it towards this ear canal and towards this eardrum. So the sound waves, as they're coming in, hit the eardrum, and the eardrum, which is really aptly named after a drum, because it acts similarly. It's just this taut piece of membrane where when you hit it, either like you would hit a drum with your hand, or like these sound waves that reach and hit it, it's going to set it into motion. It's going to vibrate, just like a drum would. And so that begins to vibrate, and we see here at the middle ear portion, we have these three bones, the malleus, incus, and the stapes. Kind of hard to tell, but it's this kind of this arm-looking thing here. And these are the three smallest bones in our body, actually. So they're connected kind of at one end here to the eardrum, which, as the sound waves hit, begins to vibrate. Connected at the other end here to our inner ear, let me back out here, to this inner ear portion, which starts at the cochlea. So our eardrum starts to vibrate, and these three bones are then set into motion because they're all connected. And the motion then travels, this vibration will travel through the malleus, incus, and stapes, and to this cochlea here, which is our inner ear. So this is our middle ear, these three bones. The cochlea is a fluid-filled organ here, and you can see it wraps up. Also inside of the fluid we have what we call hair cells, and they're these microscopic, almost like little fibers that stick up, and as you can think of maybe like, seaweed in the water, and as this vibration flows through, hits this part of the cochlea, sets the liquid that's inside the cochlea into motion. The liquid flows and moves these hair cells. They kind of bend with the motion of, the motion of the ocean, or the motion of that fluid. And the cochlea, which is this really smart organ, can kind of sense and tell how much these hair cells are moving, are bending. And it's this bending of the hair cells that they register, and they send that information up to the brain using this cochlear nerve. So here's our cochlea and the nerve, and this information is transmitted. It's like an electrical impulse, and how that happens is a process that, if you're interested in, I can tell you about. But basically it gets sent up this nerve, as long as this nerve is healthy, and then over here we have our brain. And then our brain works to perceive this information as a sound. So that's our inner ear, and we have a couple other pieces here. These canals here I didn't talk about. Those are really important in balance, maybe not so much in hearing. And then the eustachian tube here, which is connected down here to our nasopharynx, and this is where sometimes you get infections when you're a child, and that can cause your child to not be able to hear when it's infected. And if you've ever had hearing tubes placed as a child, if your child has had those, that's where those go. But overall, that's the outer, the middle, and the inner ear, and the structures that are important to hearing and how they work to come from a sound wave outside of your ear, to travel through, to get converted into something that our brain can recognize as sound over here.